Okay. Coming to the miscellaneous exercise, problem number 4 here. Okay, what problem number 4 says, prove that sine inverse of 8 by 17 plus sine inverse of 3 by 5 is equal to tan inverse of 77 by 36. Okay. Taking the LHS here, LHS is equal to sine inverse of 8 by 17 plus sine inverse of 3 by 5. RHS is in terms of tan inverse. To use the formula of tan inverse of x plus tan inverse of y, let me convert this sine inverse in terms of tan inverse. So for that, you take let sine inverse of 8 by 17 is equal to a. This is sine a is equal to 8 by 17. Put it in a right angle triangle. Here, if it is a with vertices a, b, c, here is the acute angle considered. This is right angle. 8 by 17. Opposite side by hypotenuse. And what about the adjacent side? Adjacent side will be 15. I have here tan a is equal to 8 by 15. Nothing but a is equal to tan inverse of 8 by 15. You see, sine inverse of 8 by 17 is equal to a. That same a is equal to tan inverse of 8 by 15. Means sine inverse of 8 by 17 can be written as tan inverse of 8 by 17. In the same way, let me take sine inverse of 3 by 5 is equal to some angle b. This is nothing but sine b is equal to 3 by 5. Sine b is equal to 3 by 5. Considering a right angle triangle with b here. This is b. Hypotenuse means right angle is here. Is the ratio of opposite and hypotenuse 3 by 5. Adjacent side will be 4. Then tan b is equal to 3 by 4. We have b is equal to tan inverse of 3 by 4. Coming to the LHS of this problem, LHS says sine inverse of 8 by 17. I am replacing as tan inverse of 8 by 15 plus of next is tan inverse of 3 by 4. Okay, here we will use the formula using tan inverse of x plus tan inverse of y is equal to tan inverse of x plus y by 1 minus x into 1. Okay, this is tan inverse of x 8 by 15 plus y is 3 by 4 divided by 1 minus of 8 by 15 into 3 by 4. This is tan inverse of, you cross multiply that, 8 into 4 is 32 plus of 15 into 3 is 45 divided by 15 4s are 60. Whole divided by, it is like 15 into 4 means 60. 60 minus 8 3s are 24 divided by 60. By 60 get cancels out. Tan inverse of 32 plus 45 divided by 60 minus 24. Tan inverse of 32 plus 45 is 77. 60 minus 24 is 36. Yes, this is the required RHS. Now coming to the problem number 5 in the miscellaneous exercise. Problem number 5 says, prove that cos inverse of 4 by 5 plus cos inverse of 12 by 13 which is equal to cos inverse of 33 by 65. Cos inverse of 33 by 65. Okay. For this kind of equations, means for this kind of proving LHS is equal to RHS, already I have explained you two methods. You follow any method. If you are following the first method, means using the cos formula, here right hand side cos inverse is there, right hand side cos inverse is there, left hand side plus is there. Means you use the formula cos of a plus b is equal to here. Cos of a plus b. Let me use that formula. Cos of a plus b is equal to, what is that? Cos of a plus b is equal to formula cos a into cos b minus sin a into sin b. Or else what you do, you convert this cos inverse in terms of tan inverse, and this one is also tan inverse. Tan inverse of x plus tan inverse of y, it will be tan inverse of x plus tan inverse of y formula you use, you will get it. Then finally answer will be in terms of tan inverse, you convert it into cos inverse. That way is also correct. Okay, let me use this formula. Here, this cos inverse of 4 by 5, I will substitute as a. Let a is equal to cos inverse of 4 by 5. And this b is equal to, I will substitute cos inverse of 12 by 13. b is equal to cos inverse of 12 by 13. This is nothing but cos a is equal to 4 by 5. Cos b is equal to 12 by 13. To get the value of sin a, substitute in a right angle triangle with a here. A, this is right angle. Cos is the ratio of adjacent side to the hypotenuse. What will be the opposite side here? Opposite side is 3. We have sin a is equal to 3 by 5. Means a is equal to sin inverse. That is not required here. Fine. Sin a is equal to 3 by 5. Now cos b is equal to 12 by 13 is there. You put it in a right angle triangle. This is b, acute angle. Cos is the ratio of adjacent side to hypotenuse, 12 by 13. Opposite side will be 5. Using the Pythagoras theorem, we can prove this. What is sin b then? Sin b is opposite side to hypotenuse. Sin b is equal to 5 by 30. We got the value of cos a, cos b, sin a, sin b. Taking the LHS, LHS is equal to, it is not like LHS. Considering the equation, cos of a plus b is equal to cos a into cos b minus of sin a into sin b. Substitute that. Cos will be as it is. A means we have taken cos inverse of 4 by 5 plus b means we have taken cos inverse of 12 by 13, which is equal to cos a. Cos a value 4 by 5 into cos b value 12 by 13 minus of sin a value 3 by 5 into sin b value 5 by 13. Simplifying this, cos inverse of 4 by 5 plus cos inverse of 12 by 13, which is equal to 4 into 12, 48, 5 into 13 is 65 minus of 5 into 3, 15 divided by 65. This can be written as cos inverse of 4 by 5 plus cos inverse of 12 by 13 is equal to cos inverse of, simplifying, LCM is 65, numerator will be 48 minus 15. 48 minus 15 is 33. Yes, we got that LHS is equal to RHS directly. Otherwise, you convert it into tan inverse and solve it. Coming to the problem number 6. Problem number 6 says, prove that cos inverse of 12 by 13 plus sin inverse of 3 by 5, which is equal to sin inverse of 56 by 65. 56 by 65. That one, that equation we need to put. LHS is equal to RHS. Okay. Now which formula to use here? You observe previous case right hand side cos inverse was there. Now whereas sin inverse is there. Hence you use the formula sin inverse is there, plus is there means here we need to use the formula for sine of a plus b here. Sine of a plus b is equal to, what is that? Sine of a plus b is equal to sine a into cos b plus cos a into sine b. First year formula we have studied it. Sine of a plus b is equal to, now a is equal to, I will substitute cos inverse of 12 by 13, and b is equal to, I will substitute sine inverse of 3 by 5. A is equal to, let me substitute, let cos inverse of 12 by 13 is equal to A, and this sine inverse of 3 by 5 is equal to B. Very simple it is. A is this first term 12 by 13 equal to A, and B is this second term sine inverse of 3 by 5. We have cos A is equal to 12 by 13, and here sine B is equal to 3 by 5. According to the inverse definition, I can write like this. Cos A is equal to 12 by 13. To get the sine B value, cos sine A value, because cos A is directly known to us, sine A we need to find. For that, put it in a right angle triangle. Otherwise, you can use the formula also. What is that formula? Sine A is equal to square root of 1 minus cos square. That formula also you can use. That is also right. Okay, cos A. Here is right angle and here is the acute angle A. 12 by 13, adjacent side by hypotenuse. Opposite side will be 5. We can write the value for sine A now. Sine A is opposite side by hypotenuse 5 by 13. Coming to the sine B. Here is sine B is that. Let me consider this as B and this as right angle. Sine B is equal to, it is the ratio of opposite side to the hypotenuse 3 by 5. What will be the adjacent side? Adjacent side value will be 4. What we want? We want the value of cos B here. This cos B we need to calculate. So cos B is the ratio of adjacent side to hypotenuse. That is 4 by 5. Write that as 4 by 5. Okay, we got the value of sine A, cos A, sine B and cos B. Now substituting in the equation consider. What is that? Sine of A plus B is equal to sine A into cos B plus cos A into sine B. I am substituting everything here. Sine of, what is A? A is cos inverse of 12 by 13 plus of, what is B? B is sine inverse of 3 by 5, which is equal to, what is sine A value? Sine A value is 5 by 13 into, what is cos B value? Cos B value is 4 by 5 plus of, what is cos A value? Cos A value is 12 by 13 into sine B value. Sine B value is 3 by 5. Now we need to simplify. That's all. Cos inverse of 12 by 13 plus sine inverse of 3 by 5 is equal to, here sine is there, this becomes sine inverse of right hand side. 5 into 4 is 20, 13 into 5 is 65 plus of, next right, this one 12 into 3 is 36 divided by 13 into 5 is 65. We have cos inverse of 12 by 13 plus sine inverse of 3 by 5, which is equal to sine inverse of 36 plus 20 is 56 divided by 65. Yes, this is the equation we want to prove. We got it. Problem number 6 in the miscellaneous exercise got over. Now going to the problem number 7. Problem number 7 says, prove that tan inverse of 63 by 16 is equal to Sine inverse of 5 by 13 plus cos inverse of 3 by 5. Okay. Here RHS has two terms and LHS has single term. Better to take RHS here. Taking RHS, we have sine inverse of 5 by 13 plus cos inverse of 3 by 5. Better what you do, you convert these two terms in terms of tan inverse. For that, let sine inverse of 5 by 13 is equal to A. This is nothing but sine A is equal to 5 by 13. We want tan values. You put it in a right angle triangle with A here and here is the right angle. Sine A is the ratio of opposite side to hypotenuse, 5 by 13. What will be the adjacent side here? Adjacent side will be 12. You can calculate using Pythagoras theorem. That is easy. Fine. What will be the tan A value then? Tan A value is 5 by 12. Means A is equal to tan inverse of 5 by 12. I can write sine inverse of 5 by 13 is equal to tan inverse of 5 by 12. Considering this, cos inverse of 3 by 5 is equal to B. Means cos B is equal to 3 by 5. Putting in a right angle triangle, this is right angle and considering this as the angle B here, 3 by 5 adjacent side by hypotenuse. What will be the opposite side? Opposite side will be 4. We need to convert it in terms of tan inverse. So here tan B is equal to 4 by 3. Then B is equal to tan inverse of 4 by 3. Here also B is equal to, here also B is equal to. Cos inverse of 3 by 5 can be written as tan inverse of 4 by 3. RHS we are considering. RHS is equal to, this sine inverse of 5 by 13 is nothing but tan inverse of 5 by 12 plus of cos inverse of 3 by 5 is nothing but tan inverse of 4 by 3. Tan inverse of 4 by 3. You see, it is like tan inverse of x plus tan inverse of y. Using the formula, using tan inverse of x plus tan inverse of y. Tan inverse of x plus tan inverse of y is tan inverse of x plus y by 1 minus x into y. Okay. Tan inverse of 5 by 12 plus 4 by 3 divided by 1 minus of 5 by 12 into 4 by 3. We need to simplify this. Tan inverse of cross multiplying. Let me write one more step. 5 by 12 plus 4 by 3 divided by 1 minus of, this is 20 by 36. Now simplifying, tan inverse of, you cross multiply this, 5 into 3, 15 plus 12 into 4 is 48 divided by 12 3s are 36. Cross multiplying, 36 minus 20 by 36. This 36 both get cancels. Tan inverse of 15 plus 48, 15 plus 48, 53, it is 63. 63 divided by 36 minus 20 is 16. This is the required LSS. Hence, we have proved tan inverse of 63 by 16 is equal to sine inverse of 5 by 13 plus cos inverse of 3 by 5. Okay. This is about problem number 7 in the miscellaneous exercise. Now going to problem number 8. Problem number 8 says, prove that tan inverse of plus tan inverse of 1 by 7 plus tan inverse of 1 by 3 plus tan inverse of 1 by 8, which is equal to pi by 4. Okay, here you take the LHS. LHS is equal to tan inverse of 1 by 5 plus tan inverse of 1 by 7 plus tan inverse of 1 by 3 plus tan inverse of 1 by 8. Here we will use the formula tan inverse of x plus tan inverse of y. Tan inverse of x plus tan inverse of y is equal to tan inverse of x plus y by 1 minus x into y. Same, this formula we will use between the first two terms once and the next two terms and second time. This is tan inverse of 1 by 5 plus 1 by 7 by 1 minus of 1 by 5 into 1 by 7 plus of. Now applying the same formula between the third term and the fourth term. That is tan inverse of 1 by 3 plus 1 by 8 divided by 1 minus of 1 by 3 into 1 by 8. We have tan inverse of cross multiplying it 7 plus 5 divided by 35 whole divided by, this is also 35 minus 1 by 35 plus of tan inverse of 8 plus 3 divided by 24 whole divided by 24 minus 1 by 24. By 24 get cancelled, by 35 get cancels. This is tan inverse of 12 by 34. 35 minus 1, 34. Plus of, next here it is tan inverse of 8 plus 3, 11 divided by 23. There is a common factor, we can cancel it. What is that? 2 6 are 2 17 are. We can cancel that. Now it is like tan inverse of a plus tan inverse of x plus tan inverse of y. Once again we are using that formula. Okay, according to that formula, this is a tan inverse of x means here 6 by 17 plus of 11 by 23 whole divided by 1 minus of 6 by 17 into 11 by 23. This one you cross multiply. Tan inverse of 6 into 23, 18, 12 in the sense 13 plus of, this is 187. Denominator numerator any of them get cancels. We are leaving it. 17 into 23, that is 391 minus of 66. We have tan inverse of 138 plus 187 is 325 divided by 391 minus 66 is again 325. 325 get cancels. Tan inverse of 1. What is tan inverse of 1? That is nothing but pi by 4. So this is the required RHS here. I hope you will solve this kind of equations. Here just I am cross multiplying 16 into 23 plus of 17 into 11 divided by 17 into 23. Here also divided by 17 into 23 will be there. That will get cancels. I am not writing that. Okay, thank you.